Hey everyone, I'm just dropping in to make a video for you walking through this worksheet. You'll find this worksheet in the content library, so if you navigate up back beyond your personal notebook, and you'll see that you have the content library and the collaboration space in your own notebook. This is in the collaboration space. It's called Wave Practice. This is the kind of stuff you'll see in the quiz on Monday or Tuesday whenever I have you, so I want you to be able to see how this worksheet works. So it's all dealing with the questions and the problems we've had and the formulas we've developed in our toolbox. So as we go through here, I want you to be noting what formulas you see pop up a lot, because those are the ones you're going to need to use most on the quiz. If you look at the email I'm going to be sending you, I also ask you, it's easier for you to just write the formulas on a note card. I'll have them up on the board in the toolbox, but it's sometimes harder to see. So go ahead and bring your own 3x5 note card with formulas if you want. Make sure you also have a calculator. Don't forget your phone doesn't count as a calculator. So let's take a look at this first problem. It says the wavelength of Addy-Sprague's standing waves is 33.4 centimeters and it has 3 antinodes and fixed ends at the ends. So for number 1, I just want you to draw that standing wave. So some of the keys here, first of all, the centimeter doesn't matter just yet, but the antinodes matter and the fixed ends matter. So what I'm going to do is I'm going to draw the fixed ends in first, and then I'm going to make a note that 3 antinodes, remember, that means essentially that we want to draw in 3 bumps, right? So I'm going to draw 1 bump, the 2nd bump, and the 3rd bump. And I know it's not perfectly to scale. Please forgive me. Look at that. Not that great, but we have the 3 antinodes and it's fixed at each end. Okay? So if the frequency of that wave is 3.5 hertz, we want you to calculate the velocity of the wave. First of all, keep in mind that the frequency equaling 3.5 hertz means that there are 3.5 cycles in every second. So the units are really 3.5. 1 divided by seconds. That's what a hertz stands for. So remember the formula. This is one of the really big formulas that we use. The speed of a wave is equal to the frequency multiplied by the wavelength, right? So all I'm asking you to do, if we use that format we're used to, the known, unknown, and formulas table that I taught you, we know the frequency because we were given it in the problem. We actually know the wavelength because it was back up in part 1. And we don't know the formulas, we don't know the velocity or the speed, but we do have a formula that relates all of those quantities. So that's where I got the formula that I could just put down here. We need to make sure of one thing though, because, well, not really. It depends on if the question asks you for the velocity in meters per second. If you want meters per second, you have to convert that centimeters to meters. But it didn't specify. This problem didn't ask, put it in centimeters, put it in meters. So we can leave it. We can leave the original units in centimeters. So we were told that the wavelength is 33.4 centimeters and the frequency is 3.5, 1 divided by seconds. So the speed of my wave is just 3.5 hertz multiplied by 33.4 centimeters. And before we do our sig figs, the answer to that is 116.9 centimeters per second. But we do have to check our significant figures. So we need to see, okay, this is a multiplication problem. So that means that there are 2 sig figs in the number 3.5, and there are 3 sig figs in the number 33.4, which means that my answer can only really have 2 significant figures. Because remember, for multiplication and division, it's the one with the fewest number of sig figs. So I have to stop and I have to cut my number off right after that second one. But I do need to round up. So I need to round 116.9 up to 120 centimeters per second. And I'm going to draw a big box around that because that is the answer.